My name is Stefan, and I'm from LinkedIn's Airflow data info orchestration team. Today, I'm excited to share how we empower our users with 100,000 DAGs across 2,000 independent teams using our multi-tenant Airflow managed platform. This talk has two parts. First, how we decentralized from a monolithic DAG management repository to autonomous team ownership. Second is how we built a shift-left policy framework that catches issues in CI/CD instead of production. Now let's dive in. Let me start by showing you the scale we're operating at. At LinkedIn, we run a truly massive Airflow deployment. Over 100,000 active DAGs across 2,000 separate repositories, managing 300,000 daily task executions. These workflows power everything from recommendation systems to compliance reporting. But we didn't start here. Years ago, we had a very different architecture, one that was becoming our biggest bottleneck. Let me show you what that looked like and why it wasn't working. Picture this: if you had multiple teams, imagine today we had 2,000 teams. If we didn't have this decentralized architecture, 2,000 teams would have been using Airflow for distinct use cases, all committing to a single Airflow repository. Every team stacks mixed together in one massive folder structure. Marketing DAGs next to machine learning pipelines, next to sales, next to compliance workflows. These show exactly what happened. It became a jammed gear system. One broken DAG blocked everyone. Merge conflicts were constant, and deployment took days to coordinate. The central platform team became a bottleneck for every single change. And this clearly wasn't sustainable. So we asked ourselves, what if every team could own their own development lifecycle? Our vision was simple, but it was transformative. It's to give each team complete lifecycle ownership. Their own repository, their own deployment schedule, and their own dependencies. The autonomy without structure is chaos. So we built 3 pillars: a standardized repository structure that every team follows, and a comprehensive testing requirements built into templates. And most critically, a sophisticated governance system to ensure stability. This is where teams wanted to be: autonomous, but not alone. Here's how this flows through the development lifecycle. So every team in the new architecture flow through a progressive validation pipeline. It starts in development, local development, where developers get instant feedback. Then CI/CD validates against policies. And this is crucial, using exact same validation rules that will run in production. Only after passing these gates does code deploy to Airflow. And even in production, we have runtime monitoring as a final safety net. This staged approach gives us confidence without sacrificing velocity. Teams deploy multiple times per day, but every deployment is validated. This transformation fundamentally changed how we operate. Here's what our new architecture looks like. Each team, they start with a standardized repository template, pre-configured with folders for DAGs, configs, and dependencies. Users create new DAG repositories through config-driven generation. The ecosystem automatically handles ownership sync, identity management, and deployment registration within our internal ecosystem. To follow this flow, code changes go through testing, PR review, merge, and then deploy to the final Airflow platform. Each team owns this entire lifecycle independently. The results is we went from centralized bottleneck to 2,000 autonomous teams. The deployment frequency increased from weekly batches to multiple times daily. Onboarding dropped from weeks to days. But there's a critical question. with 2,000 teams operating independently, how do you maintain governance and standards? So when you have this 2,000 independent teams deploying to a shared infrastructure, governance transforms nice to have to a mission critical. Without governance, you get chaos. Failures are only discovered during production. Unclear ownership during incidents, resource conflicts destabilizing the entire platform. With proper governance, you get stability. Errors caught pre-deployment, clear ownership and accountability, coordinated resource usage, and proactive compliance. The challenge here is how do you enforce this at scale without becoming a bottleneck again? The short answer is Airflow gives us cluster policies, but that has a minor limitation. So Airflow provides these native cluster policies as we are familiar. These are, to describe in simple words, are just functions that validate DAGs and tasks. You can enforce custom rules, reject DAG and tasks that don't comply. But here's the problem. These policies only run inside the Airflow production control plane environment. That means violations are discovered after deployment in production. The feedback loop is terrible. A developer commits code on Monday morning, waits for testing, PR review, CI/CD, merge, and then deploy to Airflow, and only then discovers on Tuesday afternoon that their DAG violates the policy. Hours and even days are wasted. Let me show you what this looks like in practice. I'm sure we're all familiar with the DAG import errors. All types of different errors, syntax errors, missing dependencies, policy violations, these are all discovered post-deployment. And now imagine us, thousands of teams pinging Airflow on call asking about why are their DAGs not showing up on the UI? And then even worse, causing critical DAG runs not being executed. That's when we ask ourselves, what if we could catch all of these errors before they reach production? This diagram shows the existing architecture for whatever Airflow has today. The code changes goes through testing, PR review, merge, publish, deploy. All of that takes hours. And only then, at runtime, during DAG processing, do cluster policies run. If there is a violation, you see a DAG import error, and then now the developers has to start over, fix the code, and go through testing again, PR review again, and merge again, and deploy. That's another several hours wasted. Think about the developer productivity and velocity. Each cycle through this pipeline takes hours. And when you catch errors at the end, you've already wasted all that time. Let's break down how this was challenging to solve. The core problem is the environment coupling. To validate DAGs, you need a fully flashed Airflow environment. It used to run only in Airflow production control plane with a database setup, settings, configuration. You can't just run validation on a laptop or in CI without replicating the entire Airflow stack. This creates a few critical gaps for us. Late validation with hours of feedback delay, complex environment requirements, making pre-deployment checks very, very difficult. A poor developer experience that you can't validate anything locally, and a limited extensibility. There's no exemption system, no emergency overrides. The bottom line here is you need a production Airflow deployment just to validate DAGs, and this blocks our shift left validation. So next is what we built to solve this. Now look like our new flow. The policy enforcement framework that is portable and can run at different stages. At local build time, developers get feedback in seconds while coding. GitHub Actions CI and pre-commit hooks, all these automated validation runs before merge. It takes minutes, not hours. And deployment time, you can still run it as a final safety net. Notice the time axis. We've compressed the feedback loop from hours to minutes or even seconds. Each deployment cycle it used to take hours, and now it gives you instant feedback. This is the shift left advantage, catching issues when they're cheap and fast to fix, not after hours of pipeline execution. Developer velocity increases dramatically because you're not waiting hours to discover a simple mistake. This policy framework consumes the same validation logic, and it runs the validation everywhere, and with guaranteed consistency. A DAG that passes your local validation is guaranteed to show up on production. The breakthrough is actually simple. It's making loading DAG and DAG bags portable. Just to give a little bit context on this, DAG bag is Airflow's component that loads and validates DAGs. We discovered that it doesn't actually need a full suite of Airflow deployment, and it can be abstracted in a few walkable interfaces. The three technical handling that made this possible, first is the coupled environment interface. We map just what's needed: a SQLite in-memory database, session factory, and various mocked settings and configurations. There's no production database required here. Second is a dynamic dependency resolution. We can inject team-specific libraries from the DAG repository into the Python path at runtime. No pre-installation needed. Third is we build directly on top of what Airflow already does. We leverage the existing native error detection. That bag already captures all of these error types, which I'm going to show in just a second. And we can run these in different contexts. The result is a production-grade validation that can run anywhere Python runs. The same validation logic, but zero infrastructure. At the core, it's very simple. For each DAG REPL, set up the environment, load dependencies, and create a DAG bag. And once the DAG bag during the DAG bag load, that's where everything runs, including all of the registered policies. Policies are just standard Python functions, and the key here is to provide these policies with access to the full DAG object, and then it can use to validate, mutate, or reject. The design is composable. New rules can be added without modifying the core engine. Policies are loaded through entry points, plugin interface, so teams can even contribute their own organizational rules. The simplicity is the key to why it scales. So this is a quick list showing you exactly what gets caught here. The table, basically, this demonstrates the power of leveraging DAGbag's native error detection. Every single error type here would break your DAG in production. And this is now caught by the same code path, the same policies, whether it's missing dependencies, syntax errors, top-level exceptions, cycle detection, validation errors, policy violations, ID collisions, or unknown executors. Notice these all show as yes for catching as DAG import errors. That isn't magic. That's because we're using Airflow, what Airflow already has, the actual DAG bag loading mechanism. The same code that runs in production runs in our CI/CD now, just in a portable environment. The code location column shows these are called at different points at DAG bag processing. Some are ran during module loading, others are during DAG processing. But they all surface through one unified interface, the import errors dictionary. This comprehensive coverage is why we catch 100% of these issues that will appear in production. We're not trying to replicate Airflow's validation. We're literally running the same validation code, just making it easier to run everywhere in the pipeline. Let's talk about cost. the time and impact. So finding an error at runtime has 100% cost. You've spent hours going through testing, review, deployment. Now you have customer negative impact. Needs to roll back, debug under pressure, hours wasted. How about finding it in CI/CD? That's only 10% of the cost. Caught after minutes, before deployment, easier to fix. Finding it during local development, that's only 1% of the cost. Immediate feedback in seconds, quick iteration, and no pipeline delays. We moved from 100% runtime cost to only 1% cost during local development instead of waiting hours. This productivity and velocity gain are massive. Let me show you next a few concrete examples of how this plays out in practice. First is the most common problem, missing dependencies. This is the classic problem. Your DAG works locally but fails in production. Why? Because it's missing some Python dependencies. In our multi-tenant setup, teams have shared libraries, custom packages, and specific Python versions. Well, these doesn't match between, whenever these doesn't match between local and production, imports would fail in production, and then DAGs will disappear from the UI. And worst of all is it wouldn't execute, obviously. And we solve this by treating an Airflow DAG repository just as a first-class citizen, as any standard Python repository with standard dependency management, and that enables us to simulate the production environment in CI, and we can replicate the library versions, auto-load them using repository metadata, and validate actual imports using native DAG, and surface these errors directly in the pull request as a CI check signal. The result here is we have 0 production import failures since implementing this, 100% detection during PR validation, and developers now know immediately if something is wrong. The second example here is maintaining identity and ownership at scale. At 100,000 DAGs across 2,000 repos, identity and ownership become critical. Without enforcement, just imagine you have 2,000 different DAG repos, and it's so easy for them to all name the DAG the same thing, ETL workflow, and you get ID collisions that breaks deployments when these same DAG IDs gets deployed. And during incidents, you can't find the owner. And for compliance, you have no accountability trail. Our solution enforces standardized format. One quick example is you enforce the DAG IDs are named as a DAG name plus a globally unique repository name. And the ownership syncs automatically from your central repository system. And this feeds into access control, automated authorization, and a whole other bunch of things. And we get complete lineage from DAG to repository to team. The outcome here is 100% ownership visibility. Every DAG is traceable to its team. There's 0 ID collisions through the automatic format enforcement, and that solves the problem. The third example, the most critical example that actually encouraged us to build this is alerting. So for us, silent failures are the highest impact operational risk. Critical pipelines that fail without alerting causes business metrics to drift, compliance deadlines to be missed, and customer features to degrade. Problems compound before anyone notices because there's no alerting setup. And these teams will basically be thinking, I'll add it later, or I'll monitor it myself. So we made alerting a structural requirement, basically inspecting the DAG bag to see each DAG and enforce during on-failure callback for all the DAGs, they have to define failure alerting in a standardized format. Failure alerting, standardized timeout policies, and integration with monitoring platforms, including automatic escalation based on criticality and SLA monitoring for time-sensitive workflows. The workflow is very simple. Define requirements in policy, then CI would validate the functions exist, and then the pull request can merge without the proper setup. Production verifies alerts remain functional. Since enforcing all of this, we've eliminated an entire class of incidents where the protocol workflows failed silently. To wrap it up, summarizing our journey, we've decentralized from one monolithic REPL to 2,000 autonomous team repositories. We've built multi-tenant infrastructure that maintains isolation while sharing resources. And we've created a portable policy enforcement framework that shifts policy validation left, catching issues in CI instead of production. The results here: 0 DAG import errors for 12 months, saving thousands of engineering hours, teams deploying multiple times a day, and governance are provided that scales without becoming a bottleneck. Feel free to connect me on LinkedIn. Thank you.